All right, we're going to start this lecture. So, last time we talked about a lot of fun things, vectors being the main part of those things, right? And hopefully at this time, after that lecture, you guys all went home and were so excited about vectors that you just dove into that, played with them, did cool things, right?
My entire world is just nothing but
I did a little thing.
What did you did a little thing with vectors?
Yeah, I created my player movement, and I also had a ball that you could use. You press one button, you press one button, and the ball would go away from the player, and another button, and the ball would go straight towards the player.
Okay, so you use the directions of the vectors to tell which way you want the ball to go, either away from the player or toward the player. So vectors have two parts. What are they? Direction and magnitude. There's two kinds of ways we use vectors. We use one, like the transform that you use. It can be used as a positional, just x, y, z, what position in space. That still is a vector, like you would make another one. It's just from origin. So that position, that x, y, and z, that vector is from origin. But you just use it as a positional one, and then the next one we use it for directionality. We use it for it's our compass in our 3D world. And we used it for a couple cool things. If we look at the old assignment, or the assignment we did, not the assignment, what I did in class, we made these awesome guys, remember? My camera's not good anymore.
That looks cooler.
Right? So we use vectors to move the guy around, to rotate him. Oh, what I did with the camera. What happened to you, camera? I must have messed something up with the camera. Two audio listeners in the scene. Oh, I know what the problem is. This guy has a camera too. That's it. Okay, so we used a lot of vectors to do these fun things. And tell if we were behind this guy. We used it to move him. We used it to rotate him. We used it to tell the distance. So if we were close enough to him, when we're behind him, when we're facing him, all of this done with vectors. And if we look at that guy, if we look at the script for this, if it opens, that's fine. We could see that it wasn't that much code, and we made a vector 3. This made the vector to the bad guy. This text was for putting the distance up. This vector 3 was my forward vector. Remember that there's two types of vector space. Everyone's familiar with that green arrow up is what vector?
Y.
It's in the y-axis. It's the y-axis. And the y-axis, if you just said the y-axis denoted as a vector, it would be what?
1 or negative, or positive or negative.
But the whole vector. Vector has three parts. What's the whole vector?
0, 1, 0.
0, 1, 0 up. Down would be.
0.
It's like boot camp. Right. 1, 0, 0. Left. 0, 0. Or negative 1, 0, 0. Forward would be 0, 0, 1. Would be forward. And that is in the world space, right? So in world space, that's what that is. There's always a forward of the world. But we showed when I was moving that character, they have a local space. I can rotate my forward to be something else. And we use that a lot. We always want to know what our directions are. What is my right-hand side? What is my forward? What is my up? We can contrast that with the worlds. The worlds never changes. But knowing those vectors is very important. So now we can get creative with how to use them. And so, again, we used them to move along my local vector. We said get some input and move me along my right vector. The transform has a lot of magic to it that just gives you that stuff. Unity, the programmers of Unity were like, we know you're going to want these things. Certainly, we're not going to make you jump through hoops to get them. So when we did like transform.gameObject.transform.forward, that gives me the forward of that game object. And so we're going to use that a lot. Right gives me right, up gives me up. We went over velocity again. We showed how to get input on axes. The dot product. That's the scary thing. That's super math. The dot product. Magic math is the dot product. Does anyone remember Does anyone remember the unit circle? We talked about it 2 days ago. Oh, no one. That's not really the unit circle. The unit circle was that big scary thing that no one liked. It had a lot of
that had
square roots in it and
solid numbers and then a bunch of fractions in between.
a bunch of fractions in between them, right? What did we? When this the very simplified version of, since we don't need to know the math, we use that to say if I take two vectors and they're facing the same direction and dot them, does anyone remember what that yields? The number.
Take two directions, then
If I have two vectors and I dot them, the dot product is it takes in two vectors and it compares them, right? So if I'm facing in the same direction, it gives me a value. If I'm to the perpendicular to that, it gives me a value. And if I'm facing completely away from that, it gives me a value. So if I take two vectors of normalized vectors and they're in the same direction, that's how I check to see if I'm facing this object, right? So the value of that vector was 1 if I'm facing it. If the vectors are exact, it's 1. If I'm anywhere not looking away from it, it is positive. We don't have to just go like, is it 1? You can do even bigger checks than that. You can say, is it greater than 0? If it's greater than 0 and you dot those two like the forward of, there was another me standing here, and my forward, if we are facing the same direction, it'll be positive in any way. As soon as I hit perpendicular, 0 on either side, looking away, -1. So I used it to show you in that, but when you're going to solve problems, there will come times where you're like, I need to solve this problem. I need to know some type of directional stuff. Can you see how a turret could use that to figure out if something was in its view? Right? So if I had my turret, and my turret just comes up and it gets on and scans around the world, and say I have a view that's out in front of me. If this guy this is my forward points straight out, and I'm looking this way with some value, and I have a guy over here. If I make a vector to that guy over there from me, and say, all right, here's my vector to that. Is it perpendicular to me? And it's like, yeah. Well, can I see perpendicular? It's like, no. It's like, all right, I'm scanning. Is it some value now that actually makes sense to me where I can see it? It's like, yes, all right, you can see him. So it can do sight. It can do all types of things. And you're going to want those things. So we didn't get too into the dot. I don't need you to know the math about the dot, but I need you to remember at some point in time when you want to solve these problems, you think back to this point in time or to Tuesday, and you go, I remember there was some stupid name for some math thing that had to do with vectors that I can use for this. And you go back and look at this, right? And we can use this more and more. But we talked about vectors, and we're going to use a little bit more of those today for some other tools. And so the tools I want to go over today, I want to go over what a ray is and what ray casting is, what casting is in general. I want to go over LERP, and then we're just going to talk about how to use all these tools and have you guys kind of spit out mechanics and see if we can solve them with the new tools that we have, right? Because we have a lot of power now figuring things out in space. So, ray casting. What are we doing with ray casting? So, a line. What is a line? Is 2 points, right? There's a point A and a point B, and it ends, right? A ray is just like a line. It starts somewhere, but it never ends. It is just a direction that goes. It's just a direction, and it goes infinitely in that direction. All right. So we use these like kind of like antenna in the game. We're blind in that 3D world, right? You nodded like when you say an AI sees you. What does that mean in computer world? If you're like, when you're playing a game, it's like, well, I don't want this guy to see me. What does that mean? What is sight to an AI component? Do you think they programmed eyes that accept light like ours do? And they're rods and pins in the light, and they accept color, and they actually program the functionality of human eyes? No, they'd never do that. It's all smoke and mirrors, right? So when you just take for granted and say that thing saw me, what does that mean? You had your hand up.
It's I'm sorry, I'm trying to find the right word. It's a component that's attached to the AI that allows them to see or hear certain things, like within like a certain distance, or within a field of vision. If I remember correctly, actually I'm blanking here.
Okay.
Was
That's it's true. There's a script. The thing doesn't do it on its own. You don't just plop a thing in the world and name it AI and automatically it starts doing things, right? It doesn't just because you say it doesn't make it happen. Yes.
They kind of like set a field of vision, like he was saying. If there's like a field in front of him that they set to where like if the player lands in that field, he sees them.
A really nerdy, mathematically generated conceptual field.
Yeah. And then for hearing, because you referred to hearing, they do like a sort of blast radius. Like if they make a certain sound in that radius or something like that.
And how close it is to us, right? So there's two things there that we just talked. You talked about giving an AI unit, a computer programmed unit, the ability to sense things in the world. That sounds complicated, right? It sounds like you're going to be AI programmer. It's like, I need you to now become aware. I need you to have the ability to see things. I need you to have the ability to hear things. I'm sure you could do smell if you wanted to.
I want a developer for something like that.
What?
I would want a developer for something like that.
No, you don't need it. All you need to do is think about what we just did. We just did all those things. With learning vectors.
You use the vectors to determine if players in front of you. And I assume you use the rays to give the AI a distance.
Well, we're going to go over rays. You could do it with that conceptual dot product thing. I said you could know when a sound is played, but all that's going to give you when the sound is played is going to give you a position in space.
Is there also a trigger tied to that?
You could do it with a trigger. Also, some of these things could be done with a trigger. So like sight could be done, the initial seeing of something could be done with a trigger, on trigger enter, on trigger stay. But playing a sound and saying, did I hear you? Well, there's a couple things you would need to know, right? You need to know the position of where that sound was played. You might need to know the intensity or the volume of that sound. But using that, when we say, all right, sound was played, we can cheat in computer world, right? I don't like we apply these rules to make it kind of more lifelike, but any sound that is played, I can give to my AI at any time. I have to cheat to make it seem like it's playing fair, but I could say, all right, a sound was played. And I'm like, okay, give me that sound. What position was it played at? This position. All right, make a vector to that. And it's like, make the vector. So that position minus my position makes a vector toward that sound. Now, I say, all right, give me the magnitude of that vector. Magnitude of that vector is now how far away is that sound? This far away. All right, how loud? Give me the volume of that sound. This volume put up against the distance away of it. Now the logic I put into the guy, can I hear this thing? No. Or yes, right? So when I'm saying you have all the tools, you just need to get creative.
So basically every AI in a stealth game always hears us. There's just a rule that says, well, they're too far away for you to actually hear it.
There's no concept of really. We create concepts here.
Yeah.
Right? Does every AI have the data to know where a sound is played? Yes. Every AI can have every single piece of data in the world, depending on how you program it. Right? When you play a card game, when you play a virtual poker game, or you play Pokemon, or you play any virtual game that has rules, right? Dude, someone says the AI doesn't have, the AI can know your whole hand. The AI can know all this stuff. We don't let it because it's not fair. Remember, we are game creators. What's a game without rules? No, it's a toy, right? I mean, didn't Minecraft eventually have rules at the beginning? Wasn't Minecraft started where you had to? It might still be like
a
this.
virtual toy. It started as like you could do your own thing. And then
But didn't you have to build up so that the creeps didn't come get you?
Yeah, that's survival, right?
survival.
The survival mode, the creeps didn't come get you. That's rules on their world, right? And so that hearing, that sight, that being able to do this, we have power to do that now. And ray casting is another way to do that. So think of ray casting and rays as a laser beam you could use in the world, a laser pointer. All right? We're putting our toolbox, we'll put a laser pointer in our toolbox. And this laser pointer, whatever I put it on, it'll tell me what I hit, right? So that'd be a cool tool to have for any distance that I want in any direction. You think about AI for cars, right? Not just what's in front of me. If I had a car that I wanted to drive, if I wanted to know what's on the side of me, I could shoot a laser out that way. I could shoot a laser out this way to know what's in front. When should I stop? Stop when your distance gets this much. Start stopping. Start, when should I change lanes? Should I move away if something's trying to ram me off the car or ram me off the road? I'm talking a lot about AI, but do you remember when we did jumping in generic behavior? And we had the logic of, am I on the ground? But we only had on collision enter. And on collision enter cared about if I hit the wall too, so I could wall jump. Like, how would we give the concept of feet to our player?
We'd have to put a new collider down on the feet.
You could do it with a new collider. You definitely could. Or you could shoot a little antenna down just below the guy to say, does this little antenna hit something? So you could think of raycasts like feelers or sight. It gives us more ability to interact with the world. How do you think mouse clicking happens in a game? People, I mean, you like to put your mouse on things and click them, right? Click buttons, click objects in the world. Okay, so they shoot a ray through your mouse position into the world, and says, what is this hitting? And it says, it's hitting this. And so now they do cool things. They highlight it. They say, what do you want me to do if I'm over this guy? Do this. So rays are used for something called mouse picking. So we're trying to give you all the tools you need here to do the things that you want. Now, there's some other fun math that goes into mouse picking, but those are things that you can use rays for. And so since we did vectors, let's take a look at ray casting in this space. All right, so I got my guy, and we had this functionality again, where I can do this. So what I want to do now is not am I behind him and close enough using that. I want to know when am I looking directly at this guy. So if I wanted to, do you ever see when you're looking at something in a game and it becomes your target automatically? Like if I'm just rotating my guy and he's like the closest person to me, because they do a lot, like combat now is very user friendly. It's not like it used to be. Combat now is like, am I anywhere near a close guy? And they're like, yeah, it takes me to him, and like, we'll do this, and like, will push me over this way, and I feel awesome, because they want to make you feel awesome, because that's a designer's job. Batman, and a lot of people have it's called soft targeting. So soft targeting is,
Assassin's
yeah, is this guy in my range, or am I kind of targeting him? So kind of targeting him, what does that mean? It means this is what I think you want to do, and I'm going to make you do it so you don't have to feel frustrated. And you're going to feel awesome when you do it, because I'm going to make you feel awesome. Same with the old headshot gun from Halo, the handgun, the pistol from Halo. A lot of head detection magnet stuff there. So what do we do with that? We're still going to use vectors for something like that, but we're going to get rid of our other detection stuff. and I'm going to show you guys does everyone get the concept of what a ray is? And like just a giant and laser. You're going to use they're used a lot. These giant lasers, raycasts. And we'll do that with the same thing here. We're still going to move. We're still going to rotate. But I don't care about this right now. I don't care about my turning green and red based on this. I'm going to turn green and red based on something else now.
Can you zoom in on go?
Yep.
Okay.
Okay, so what I'm going to make here is I'm going to make a ray. Doesn't have to be public or anything. Ray, I'm going to call it R for ray. And to make a ray, I guess we could do new. Let's look at the pieces of a ray, all right? R dot direction, right? So a ray has 2 points to it. It is a vector, but it has 2 points to it. It has where it starts and where it's pointing. And its magnitude is infinite. All right? So just like if you shot a laser, I don't know how long lasers go, however long light goes. But the origin of our, so what I want to do right now is I want to send an infinite laser out in front of my player. And I want it to tell me when it touches things and tell me what it touches. Right? Again, we are blind in this 3D space. We need information. And we can get information. This is how we get information. Figure yourself being completely blind so you can now get information. So if I want to start this from me, this is going to start from me, and I want it to go out in front of me. Where's the origin of this?
The origin of the player.
The origin of the player. What holds that information? Game object is a thing, but that game object has a buddy component that always stays on it. Transform is game object's buddy component, always there. Holds your position, rotation, and scale. So let's do that. Game object's buddy, and position. Right? So I set. Why doesn't it like that? Do I have to make a new ray? You're a liar. Okay. Probably close it out like that. And it doesn't like that logic right there. Okay, so I know what my position is, and if I want this thing to go in front of me, if I want it to shoot out in front of me, this laser, what would I be looking at? The transform holds this also.
Right.
In front of me. You said right, to the right of me. Forward. Right? So I'm really just talking the screw. I'm not like saying any magic, crazy words here. I'm saying the words that are just like, if I want this thing to start at me, it would be, okay, start at my position. If I want this thing to go shoot out in front of me, I will say, all right, make its direction my forward. You can talk this out as a human being. You don't have to be, the direction of this ray is GameObject.transform.forward. We have a ray. We have a ray that's going to constantly be attached to our character. You won't see it. I could probably draw it. I can't draw it. I'll draw it. How about that? You won't see it in game. Debug.drawLine. And this takes a vector3 start, which is r.origin, .origin. And the end of this line I want is r.origin plus r.direction times 200 point. Maybe this will work. I hope it works. What color you want it to be? Purple? There is no purple. I think there's magenta. It counts as purple. That's all you get. We got magenta. That's what we got. And the duration, I want the duration to be infinite. So we're going to see if this line draws out in front of me. Should. And I need my scene to be able to see this. It's debug, so it only draws in the scene. But do you see that purple line out in front of me? So it's imaginary in the game, but we made this ray. Now, I just made the length 200, so it only goes 200, but that ray goes on forever and ever and ever. But I have that now on my character to do as I please with. To figure out any information I need, I have this line, and I could put them anywhere I want. So we now have a new tool, laser pointer, which is called raycast, if you ever wanted to use that. So let's do something with it. Let's do, I made a ray, and we have to cast this ray out. Think of like you're fishing. Using this ray to cast it out into the world to see what it comes up with. So we ray cast. There's other things called sphere casts. There's capsule casts. There's box casts. So if I wanted a fat ray, I wanted something that was bigger than just a single line, I could use something like a sphere cast. And you may want a fat ray at some point in time. But so if I look at raycast, let's look at the physics.raycast. Okay, so we have a function here. If you remember, I'm going to zoom way in. You guys can't read that at all. So remember talking about how we looked at functions. The parts of a function where there was what are the three parts of a function? If anyone remembers. A function is a box that does what?
It brings something in and then changes it and then gives you returns you a component.
Something, yes. So the first thing, if it returns you nothing, it's everyone's favorite word with functions because it's the most functions they see. Void, if it returns nothing, and people think that that's like what a function is called. It's called a void. It's not. That is the return type. So the return type is what the box spits back out. Okay? So if you could read this, raycast, the first thing on when you're reading this is, can anyone read what that is?
No.
No.
Bool?
It's bool. All right. So this thing spits out a bool. That's all that this spits out by default. It is a line that tells you this raycast function says, I hit something. And that's all it says, is I hit something. And the name is raycast, and then it takes in a couple things. And we'll make what it takes in a little bit easier in here, because we already have something for that. It takes in an array. So we just made an array, right? We made an array called R. And so I'm going to put in R because I know it takes array. I'm going to hit comma. Max distance. How far do I want to check out in front of me? 10 wouldn't be much. Like this much. Well, what I did with the draw line was 200.
So you make it public so that you can adjust it.
I can adjust that. If I made a variable, if I made a public variable for adjusting that, I could adjust that on the fly whenever I want to do. That's correct, which is probably a good idea. But it's a good idea I'm not going to do right now. Because I want to stay consistent with what I'm drawing. Because there's a big difference between what's happening in my logic and what I'm drawing, and that's what confuses a lot of people sometimes, is because they're like, the drawing looks like it's doing this, but it's not functioning. Well, the drawing is just drawing. It's separate from what's actually happening. Layer mask, don't care. Don't think I care about the rest of that stuff. Oh, I do need something else. I need information about this. So, do you remember when we did on collision enter? Do you guys remember that function? Even in generic behavior, when you use on collision enter, there's a way to tell information about the collision. And it was that thing that was passed in. It was the other, if you remember it. If you remember other, on collision enter, if I was going to write that function right now, it would be void, don't return anything, on collision enter. And it took a collision other. And so this thing that was passed in, this collision describes a collision. Meaning it gives us information about what happens when two things collide. So there's something like that for rays, and it gives me information about the thing I hit. And I need to get one of those. So to do that, I'm going to make something called a raycast, if I could spell, a raycast hit. I'm just going to call it our hit. All right? And I need to use this, and you guys don't really have to care about this completely, but out our hit, and it doesn't like that for some reason. Max distance, it goes in between them. Now again, I'm not testing you on this information. Doesn't need that there. What I'm doing here is, you can remember this, what I want you to do is when you have a problem to solve, I'm showing you a tool that you can get more comfortable with later if you need it. Like I'm introducing you to the word that hopefully you remember when you say, man, I really need to know if my guy is facing this. Or I really need to know. You know what a reticle is in a game? It is a raycast that shoots from wherever the reticle is to tell you if you're over top of something. So first-person shooters, you know in first-person shooters they don't use bullets most of the time? You know what they use? Rays. Or line traces. But a trace or a ray, right? They don't shoot a bullet, not a bullet made everywhere that goes, this tiny little bullet is going to fly through the world with perfect physics. Most of the times it's an instantaneous raycast that says, because that's more fun to play with, right? It's, my reticle's over something. And it's like, well, did you account for the wind? And there are certain ones that do this. Now, it's not all things that are like this. But if you're playing like Destiny or a game, not a simulation, but if you're playing like a very gamey first-person shooter, it's probably done with a raycast. When you're doing something like a sniper rifle in like Call of Duty or like Battlefield, and you're like, I have to account for the drop and I have to account for the gravity, they are doing some different things there. Or like a grenade launcher that's going to be a projectile that actually has physics on it. But a lot of these things are done with raycasts. Point, is my reticle over the character? Yes. Did I hit button? Yes. Pop a ray out. Did it hit? Because that's more fun. The instantaneous feedback is better than going like, oh, I counted all these things. Yes?
So what do, like, kind of sniper rifles that have bullet drop like that, what do they actually do?
So, I don't know exactly what every game does. There's multiple solutions for that. You could send a projectile with gravity on it, given the force that you could actually say, this is the force that's going to go on this thing. Put the wind on it, put all those things. Or, what I imagine happens is, I imagine they adjust their raycast based by that.
So they have an arc in the raycast?
What?
They have an arc with the raycast?
they can either have an arc or they could just make it slightly go to a different offset, right? So they account for the drop of the bullet or account for the wind in the world. So like if I had a raycast that was shooting straight out from me, and I said, well, account for gravity at this constant rate, a sniper rifle probably shoots like very, very slightly down. So up close, you'll never notice it, right? You'll never notice the drop up close. But it's possible that drop over the farther the distance gets away, if I just angle that ray down a little bit, that becomes very significant. So the farther I am away, I really need to account for that because that angle is going to get bigger and bigger and bigger and bigger and bigger, even if I change that in a small amount. Make sense?
It's just sending out a new ray every couple of seconds to adjust for the drop. Is kind of
what probably you're getting a little more complex, but if they do it with a projectile, you can just use physics on it. Super small high speed projectiles have issues. They have collision issues and collision detection. This where you make something like very small, like the size of a bullet, and send it through the game as a speed. Like even if I made the pong ball, if I made the pong ball go at a speed of like 1,000, you'd be hard pressed to keep that collision detection to go like that's actually going to stay in here. You can crank it up so fast that it just skips right through the collision. Yeah. Right. So that's the reason we use rays. And so it's probably when you actually do the sniper rifle, it's probably did you hit him and then just has a delayed reaction.
Okay, so it sends out a ray first.
It sends out a ray modified by whatever gravity is, and that modification isn't really gravity pulling that down. It's you saying 0.2 degrees tilt down, and that is the drop on this because the velocity is that. So whatever, they make some math thing up for that. And then they say, all right, hit button. Did I hit you? And it's like, yeah, you headshot me. And it's going to go like, okay, in whatever the speed travel was, in 0.3 seconds, register headshot on this guy because it happened.
Okay.
Right.
So what about with the game like Sniper Elite, where when you get a kill cam, they actually shows a bullet projectile, and then the bullet projectile lands inside of the AI character, and then it fragments.
It probably follows. They create the line. They save the line that was created, and then they just say add a game object to that looks like a bullet, and make it travel in slow motion to this guy.
Okay, so like as you hit the trigger or fire, a ray instantly gets made, and then like a projectile will follow that.
You can do that, but I'm saying they're probably not checking collision with the projectile. Right. They're probably faking that afterwards to show you something awesome. Like once it's registered, they're like, all right, now let's make. There's a lot of faking. There's tons of smoke and mirrors in games, and like you're getting.
Sounds sketchy.
You're getting some big, pull the curtain away stuff. It's not like you think it is, and so I'm not sure if that is if that's the way that they do that. I'm saying I've solved that multiple times, and that is the way I would do it. I've done the projectile at super high speeds. I've got the lack of collision. I've done the dropped ray, right? That is good. That is going to give you a shot. If you hit it, and you can modify it based on wind and all it is, it's not the ray's not getting hit by the wind. You're saying mathematically, I'm going to create a conversion. Gravity makes this gun's speed, velocity, bullet speed is this, gravity is this, that converts to this tiny little bit of an angle drop on my sniper rifle, right? Wind is this much, it means this tiny little bit of rotation on my Y on this sniper rifle. Those little tweaks make the gun different, right? But it all comes back to math. So the constraints in this computer world are what we're using. These are the tools we use to solve these things, right? And so I drew this line. This tells me information about the thing that was hit. So if I want to know what did my ray hit, I need a raycast hit container to kind of tell me that. And I pass it into my raycast hit function. This raycast function returns only if I did or didn't, if hit something or did not hit something. True or false. Sometimes that's not good enough information for me. Most of the time, it's not good enough information for me. Most of the time, I need to know what the hell did I hit. So I get that with this raycast hit. And so now this code here, if raycast hit, I could take this code, and I'm going to leave this here. I could take my enemy. Did I tag him as enemy? I did not. I'm going to tag this guy as enemy. I don't have enemy on here. Uncool. Enemy. So tags are just tags. They're names that you can give to things to test them later. So this thing is an enemy now. All right. And instead of doing that math to find this out, I'm going to use a raycast for it. And so I know that this guy is tagged as an enemy. And so I'm going to do if I hit anything. If raycast returns true. I made my ray. I attached it to me. I said, go forward on me 200 units and see if you hit anything. And it's like, if it's true, let's hit something. Let's just go this. All right. So this should see when that line hit him? I'll put the next part in. It's hard to see with this camera. I'll change the camera here so we can really see it better. We'll put the red in so we could see that. Okay, now when this line hits this guy, I'm going to turn green. See that? We have a super awesome laser pointer, magic laser pointer that tells us things now. Called Raycast. You can have this video, you can have the code later if you want to look at it. The more important thing is you have a term to use when you need to solve a problem. And you have other ways to solve that problem. There are multiple ways to solve problems in games. We are smoke and mirrors. We are in a make-believe space ruled by whatever the hell we can come up with to get things done. You could probably put a big, long cylinder out in front of the player and just do on-trigger enter stuff with it if you wanted to. But it gets funky when you do that stuff because you have to manage multiple cylinders. And so there's a lot of different things. The problem with this is if I add another object to the world, big sphere, okay, let's add this object to the world. And let's scale it up a bit. Is this an enemy?
You haven't labeled it as an enemy.
So it shouldn't be an enemy, right?
Well,
I think I'm below it. Yeah, I think I'm below it. All right, that should be fine. Okay, that's not an enemy, right? Right? That's not. If I said if that was a part of a building, right, that had a collider on it, and say I had a laser that killed. Like, the logic on my laser was, if laser hits you, die, right? Would I want that thing? I mean, it could be cool, but would I want that thing lasering through the world, deleting everything it hit?
Normally not.
Normally you would say, oh, laser. If I turn that laser on, I would like, please tell if you hit an enemy. Because I do not want Cyclops laser tearing through all of my buildings and deleting everything it sees, right? So I didn't do that, and I just put a sphere in the world that was not tagged enemy, and it was like, no, that's a thing. Because Raycast says that's a thing. And all I'm checking for is, did you hit something, laser? And it's like, yes, I hit something. Turning green. That thing's gone. I can put delete in there instead of turn green, it'll kill everything it hits. Right? If you want to see that, it's fun, I guess we can do that real quick.
What is the void at the bottom?
The what? The void?
Yeah. The one you're looking
The void is the return type. So don't call them void. This is a function. What is the function at the bottom of the script with the return type void? So if you wanted this, we could go, if Raycast hit R hit, if we want to delete everything we hit, we could just say R hit dot collider dot game object dot destroy.
Wow, they actually have this.
Yeah. No, it's actually, I'm sorry, it's just destroy. It would be just destroy R hit dot, I don't think I can get game object off that. The collider dot game object, because destroy takes a game object. So now I do have a laser beam of death. You're dead. You're dead, right? So I don't want to do that. I mean, I guess I could do that, but I do want to show you more functionality out of this. So what I really need to do here is get rid of this else here. Actually, let's cut that. And what I want to check to see is, did you see how I just used that game object to destroy? I could check to see if, after I know I hit something, right? So this is how you have to start thinking. Even if you were a game, even if you never programmed, you should start thinking like this. Even doing system design. This is not like, think about it not like a programmer, think about it as a system. I need to know when I hit this thing. Okay, how am I going to figure that out? I need sight. How do I figure out sight? This is why it's important in your system design to understand these programming concepts, because you're going to have to think about how this is actually done. Right? Your logic flow, your rule set is only given to what you can do in the world and how that's perceived. So if I did if R hit, because that gives me my information, and I can only get the collider off of it, game object dot, well, I could probably get this off the tag, but it's just easier if I do it with this so you understand it. Tag is equal to, what did we tag our guy? Enemy. If that happens, now we know we're an enemy. And if it doesn't happen, and there's one more thing we have to do here also. We still need this else down here, because yeah. Okay, so now I'll go to the enemy first, right? Enemy. I know you're an enemy. Awesome. I could kill you, and I can do whatever I want to do to enemies. Innocent ball here that never did anything bad to me. And he's like, okay, you're cool, man. You're cool. You don't have to die. But this dude, he has to die, right?
But after he dies, the sphere becomes a witness.
It's a witness.
Well, then I would make a tag called witness. And when they became tagged witness, I'd make a variable called isWitness. And I would say, are you this thing? Yes. Are you tagged as a witness? Yes. Now I kill you. Do you see? Do you see?
Right,
So you just came up, but that's interesting, right? Given the things that we had in the scenario we just built, you just came up with an interesting game mechanic. The mechanic of witnesses, right? Now I'm sure there's a lot of bigger rabbit hole to go down there, but we have the logic to go, all right, we know to hit something. We know to say, are you cool or are you not cool? Or do I care or do I not care about you? Because we can find the game on, we can send a laser out, say, I know you're there. What are you? We can find what you are now. If you're a person, they can have a variable in them that says, is witness. And if I know, I can check a tag to say, are they a bystander? So we could have enemies and we could have bystanders, right? And bystanders can become witnesses. So we could start using these tools, we could start developing more interesting mechanics, but we have the tools to do so. And you're just getting baby's first toolbox right now, right? You're getting the Fisher-Price plastic yellow hammer. You're getting the tools right now. To become a master with these tools, you have to use them. And when you use them over and over and over again, those things that you're talking about, when you have to sit around with your friends and you're like, well, let's make them a witness. And if witnesses sees you, what does it mean for a witness to see you? We have to actually find some, we can't just say the words that it's magically because we want them to. These bystanders are going to see this thing happening. We have to say, I did something. What did you do? And I have to flag me as I did something bad. And then witness is over here, and he's like looking at, can I see you? Yes. Are you flagged as have done bad thing? Yes. Witness now turned, or NPC now turns, flags himself as witness. Now he's killable. And now I have to go like, well, I can see you. And I'm giving you the tools to build that scenario. This is where it gets fun, because this is when anything becomes possible once you guys have the tools. Those pie-in-the-sky discussions that you have with your buddies about wouldn't it be cool, that's so that the joke about designers and the things you never want to hear from them as a developer is, wouldn't it be cool if? Because wouldn't it be cool if means that they either went out the night before and had some beers and came up with this crazy idea without any thought to feasibility for the system, right? Now, with these tools, you guys can say, wouldn't it be cool if? You're like, yeah, that'd be really cool. Let's not just say that would be cool. Let's break down to see if this is actually a possibility based on what we know. And now you guys have the most powerful tool in video games, vectors, a really good Batman utility in dot product. You guys, if you guys play with raycasts, you have a huge blind person. What's that called? Cane? Yeah. Right? Well, think about this. You are trying to become Daredevil. Like we are giving you the tools to train to be Daredevil. You're put in this 3D world, you have a box in front of you, and you need to find things around it. And you just got a big tool for that. And we'll use it on another way to do that. Yes?
Does array go through game objects?
A game object can be tagged to say, I don't care about rays. There is another concept that I'm not getting into. It's a little bit more advanced. We'll get into it later. And it's actually called layers. So you can put things on a physics layer that says, please do not care about rays. Rays do not care about this thing, right? You can put things on a physics layer that says, the character does not care about it. There's all ways to shut different types of physics on and off, or collision detection on and off. You may want to do that at some point in time. I'm not going to go over it now because it's a larger thing. But if you look now you opened it up. You opened up the box, and everyone's going to hate you for it. No, it's not that bad. Get him. So watch. I'm going to put a comma here. Do you see that layer mask right there? You can't see it yet. I don't know why I'm asking you that. The next parameter in this function. So the first parameter was the ray, which was R. The second one was the raycast hit, which is the information I need back from that ray. And the third parameter, 200, is how far I want to check that, right? The next parameter is layer. What layer does this thing care about? So yes, your answer is yes, 100%, and it's built right in. It's the next step of using these things, is caring about what layer I'm on. All right? So that is not the only thing that we can do with this, right? That's a great thing. That's the first thing that you can do with this. If I made a first-person shooter and I wanted to just shoot a ray down the middle of the thing and say, wherever that ray hits, I kill, and then draw a little reticle right there, you've now made a first-person shooter. Rotate the camera like I was doing, be able to go up and down. You're taking your first steps to making your first-person shooter. Very simply, we could write that code if you wanted to. Everything you have learned in the past 2 lectures have allowed you to start baby's first-person shooter kit, right?
So we're good then, we can just drop out and start again.
Yeah, because every single first-person shooter that's made out there makes it, right?
Yeah.
No, very few make it, right? What? No, you couldn't make the new Call of Duty. That is one of the things that happens with game development. You get a core mechanic down, and you're like, I can shoot things, and it's like, yeah, you're not even close to Call of Duty. If it took 100 people 4 years or 3 years to make that, they are grossly misusing their funds for that company, right? That is not what makes Call of Duty Call of Duty, right? So if 5-month game design students could come in and start that, what are you doing with your time? Yes.
What about a mechanic for picking up objects?
Picking up objects, and this is the same thing, right? So picking up objects, and you'll see this in another class that you guys have. If you wanted to have a gun that was like a gravity gun, same thing. You would say, where am I facing? Put my reticle on it.
No, I mean like you walk up to something and you can hit and you can initiate it, and the character picks up the weapon. Let's say you have no weapon at this time.
You have no weapon, right?
And there's a weapon on the ground.
So it's not like, it's smoke and mirrors. Think of the easiest way to do this. We have a weapon, which really wouldn't be a weapon. We have a weapon power-up, which represents a weapon, right? What do I have to do to pick up that weapon?
Either walk over to it, hold a button, press a button.
Press a button or walk up to it. It doesn't matter. Either one's going to work, right? Whatever one you choose. But that whole thing is, what tool do we have to know if I've touched that thing?
If you have,
We probably don't want it to block me. It's a power up, but there's another one. On collision enter or on trigger enter. Either would work. Say I'm touching this thing. So if I'm touching with this thing, which you can use on trigger stay or on collision stay, say only if I'm in this on collision stay function, which you would have to write, say if input is pressed, then pick up weapon. And what does pick up weapon mean to us?
Destroy the game object that's on the ground and then.
Destroy the useless power up that says give me a thing, right? And then we'd instantiate a real big boy weapon, the real thing that actually shoots, and we would attach it to our skeleton's hand. That's what we would do. And then we would make a function inside of our player that says shoot gun. And it would take in a gun to shoot. And it would call the gun shoot function.
Do we want our player skeleton to still hold the gun like this?
Well, your animator, that's not your problem, right?
Okay, so that's not our problem?
No, your animator is going to make your animator is going to give you a skeleton that has a bunch of bones in it. So if you want to hang a sword, you're going to put that sword on your back, put it at spine joint 01, right? If you want to put something in your hand, you can look through that entire skeleton and get all those pieces. Your job is not to make the hand close. Your job is to attach the gun to the hand.
Okay.
Right? And then you attach the gun to the hand, and then you still have to make it look like it's shooting that to the center of the screen correctly, if we're making a first-person shooter.
Isn't that still an animation, though?
Look means, yes, it could be animation. That could be the animator's job to align this socket. I don't know whose job it is. These all get work. Align the socket so when you put a gun on there, it points towards the center of the screen. But there's some finesse, because most of the times the gun kind of angle this way. They don't come out the center of your chest, which is the ray that we would use for the camera. You have to align the ray to the camera and project the ray. To get good, no, you're not ready to make Call of Duty is the answer, because there's a lot of other issues
That's what we were looking for.
associated with that. But am I saying, like, when I said that you have Fisher-Price first toolbox right now, you have heard the words. Some of you might have went home and played over the last 2 days with some of the things we learned with vectors. You've heard the terms, The only power you guys have now is maybe to recollect that I know there's a thing that does this. And I guess you could have said that before you came here. I know there's a thing I don't know about that does the thing that I want to happen, right? But now you have heard and seen that the thing there is going to happen. And hopefully, if you take this information, when you're thinking about your games in the future, you're thinking about them in terms of knowing the solutions for these things and having the pieces to do so. So this, again, we just have a hammer. A hammer can be used for a lot. Can you break a window with a hammer? I mean, was the hammer intended to break? Would someone say, like, I need to break windows? I'm gonna make a hammer.
It wasn't intended, no, but you can still, yeah.
Okay. So, and there's actually, I think there's specific window breaking like hammers, right? There might be one. But it was made to pound in nails, right? And so you're going to see that these things have multiple uses. So just this little third person shoot the ray out in front of me is not you think about these things as tools to just solve multiple problems, not just the exact situation I just showed you. Sight is a great.
Use it as an auto.
You could use it as an auto target. You could use it as, like we said, not just sight. We could use it as bullets, like instant trace bullets. We can use it to stop me from jumping. I can tell it can become my feet. A little line that says, just like I said, did this line. You know what? What time is it? Oh, we got so much time to bore you guys. We're going to do it. We could totally do that. So, do you see how I made my ray here with transform forward? Okay. If I make this with transform up and negate that, I think it's going to let me do that. So what did I just make? I took that ray, starting at me, right? That was pointing outside. What did I do with it? Pointing forward. What did I do with it?
You made it point down?
I made it point straight down, right?
Negate up? Okay, negative.
Negative up.
Negative up. I could do this, right?
So the negation has to be in front of the game object dot transform. You can't just do game object dot transform and then down.
There is no down.
Okay.
So there is no down. You have to think when people make these, they also think about. You guys don't think about this, and we're kind of blessed, but with oodles of memory when we work on computers. But when programmers do these things, like we're going to make up, it's like, do you want to store another vector for down? They're like, no, that's stupid. Just we don't need to waste the memory. Like you would talk to a real programmer, and they would say, it is completely unnecessary to even give you forward, up, and down, because that is totally findable from the transform itself. They're like, well, we want non-programmers to use this, so we're going to give them forward, up, and down. So it makes more sense to them. It's humanizing that at the cost of memory, right? Every single game object you has now stores 3 extra vectors in it. And those 3 extra vectors are, if you have 20,000 game objects in your scene, times 3 extra vectors, how much memory footprint is that putting on it? This might not matter for like a 20 gig game. It probably does, because there's a lot more than 20,000 objects in it. But when you start saying 3 extra vectors all the time, we have now put on, if you did a phone game, if you put a significant amount of memory footprint on there, you have a problem, right? Video games have limits. The reason you have awesome graphics cards, and the reason you have awesome processors, are because they've had these limits. That's why memory is getting bigger. We can handle more things. So not making, it sounds stupid, so why don't they just have down? But then someone who's in knows, like, it's even stupid to have forward, up, and right?
That makes sense, yeah.
So I just put that down. I don't want it 200. I want it more like, I think my capsule was, let's do 3 and see what happens on magenta. And I don't want this stuff anymore. I don't want this anymore. I know, it's the worst. Don't comment it out. You gotta get cool with deleting things.
You gotta clean up your code so it doesn't look like shit.
Whoa, I'm recording this lecture. I'm gonna watch the language.
I had no idea.
So now if I took this, it's okay. Everyone should be an adult at this point in time. I have this cube, right? I have this cube, and I'm going to put in, I'm going to add a tag called floor, all right?
Why didn't you use a plane for the floor?
Because no reason.
Okay.
A plane would work fine. But so now I have something tagged as floor. And if I want to say raycast hit if our hit dot collider dot tag is equal to floor, what do I want to do? All right. I want a bool that says, in my update here, let's just put it out here. I'm going to put a bool. Doesn't need to be public. I'll make it private. And I'm going to call it can jump. With 2 atoms. Equals false. We'll just make it equal false first, all right? And so, where do I want to do this? If this is floor, when I hit the floor, I want to be able to jump, right? Okay.
So if you're on the floor, then you go.
Can jump is true,
Equals true.
right? And when I could do on collision, and if I don't, if this thing doesn't hit anything, that means this went out of its space. I can't do anything anymore.
Outside. Can jump equals false.
Well, we can do that. I mean, this is not the most elegant solution to this, but it still shows you.
Is there a button bound to jump, or is it we're just gonna start jumping when we touch the floor?
Well, we gotta program the button.
Yeah, the button's just right here. It's if input dot get key key code.
Let's be different, maybe.
Nah, we're not going to be different.
Don't upset the other gamers.
And the other thing we care about was space pressed and
Is can jump equal true?
yep, and can jump. Could just leave it like that, but we'll be explicit. So I want my rigid body. I think I have that already.
Yes.
RB dot add force. New vector 3. I'm gonna make them jump real high. I don't know if this is gonna work, but you'll be able to see a different use of this, and maybe we'll be able to see the little raycast. It wasn't super high.
Well, I think he still has gravity working on him because he even came back down slowly.
He does have gravity still working on him, unless I didn't do that. Maybe 200 wasn't enough.
Well, I think that might be because it seems like the same thing when you set your y direction at 0 instead of.
I probably set my y velocity to 0. Yep. That's probably what happened. Where's that at? Yeah. RB velocity equals this plus this.
You might want to dump down your jump.
It's gonna go flying now.
That's what I said. You want it.
So let's go back to what we had there. Let's put a regular jump on that.
I have a question for you.
Yes.
In your if statement, when you have the logical and, then would you consider that a comparison operator?
A comparison operator.
Yeah. So is it comparing the truth values between those two?
Yes.
Okay, just. we had an issue with that the other class.
The exact phrasing was.
The only problem is we can still do this.
I didn't do get key down. That's the problem. Not enough.
You're going back to that again.
Well, I need the force mode. It needs to be an impulse, not force, or not a force. All right. Whenever I want to test things, I make them ridiculous numbers because I watch people sit around and go like, I'm going to add 1. And it goes, and like, add 1 more, and it goes, and it's like, add 1,000, see if it works, and start working your way back. Right?
We have one.
And start taking chunks out of that. Still too much. Alt tab. Still too much.
Shade's still doing the whole, you can still jump. You can still keep hitting the space bar.
Yeah, I should not be able to hit the space bar right here. Again, because of that ray cast. So something's wrong with my logic here, right? So if this ray cast hits something, and this is what's wrong with my logic, I never turn it to false because that doesn't come in here. Because it only comes in there if the ray hits something. Once the ray stops hitting something, then it doesn't actually work. And you can see that my 3 was way too long there. This should be something more like 1.5. Still doesn't care about it. No, there's the little line. You can see it right there. That line's still there, but that line should say, if this raycast hits something. Oh, this is my problem. I'm drawing it at 1.5, but I still had 200 on the check for the ray. So I told you that, like when I started doing this, I'm like, the drawing will throw you off on making you think you're doing the right thing. The drawing is just drawing something, and they have 2 separate values. The smart thing for me to do would be make a variable that says ray length and pass that into both places. When I changed it there, it would do both. If I was smart, I would do that. But now, so you can see as soon as that ray hits, I'm allowed to jump again. And that's only on my feet now. So that is now a little line that represents my feet. Could you do that with another trigger? Sure you could, for the logic. But I got a tool, laser, and I'm going to use it.
Instead of an array, you can just use a collider from the feet, right?
Yes, and there's some of you who are going to get this new tool and think that everything's a nail, right? You're going to get this hammer and everything will become a nail. And I'm going to see you put out something that has 700 rays out in front of it,
Porcupine.
right? You're going to try to do something crazy. You should do crazy things with this. I have done crazy things with this. Things I'm not proud of. Right? I have not shown them to you. But it takes that time and that craziness to do these things, and that willingness to use these pieces to actually start figuring out how you want to use these things. So Raycast is a huge tool based on that bigger tool that we learned on Tuesday, which was vectors, right? This is still the same. We're in the same space of showing you how important those stupid things are. Like how much they're going to affect your time in this 3D space. There's so much you can do with them. So the last thing I want to show you guys is it's a term. You don't have to understand how it works completely. But the last thing I want to show you guys is something called LERP. Has anyone heard of LERP? LERP. LERP. You heard of LARPing? Like lightning bolt? Lightning bolt? LARPing, right? No, this is LERP. Listen up. LERP. And it's short for linear interpolation, right? Linear interpolation. What LERP does, and you'll want to use this at some point in time, if you didn't have an animator and you wanted to make a moving platform, right? You said, I want this thing to move on its own and just over time move this far. You could do that with velocity, right? We've done that. What if you wanted a color to change over time? What if you wanted a value to change over time?
Strobe light.
What?
Strobe light.
A strobe light? Well, yes, that you can do those things. But so when you see LERP is important, if you wanted a camera to be very soft and to like fade into things, you want these things to happen sometimes. Sometimes you want a value to change over time, right? Well, what LERP does is it gives you the ability to say, I want to change this thing over time, and you can do it with a lot of things. You can do it with a float, you can do it with a vector, you can do it with a color, but it says, I want to change this over some time. And it's just a useful tool that if you said, man, I would really like this thing to go from this position to this position in 1 second. You could totally do that with LERP. If you said over 1 second to like, if I was like powering up and I wanted my material to look different over some time, I could use LERP to do that. Over 1 second, go from green to red, right? And it won't just flip from green to red. It will go, all right, slowly over the amount of time, take this and use LERP for it. So you could see that if you hear it, again, I'm just telling you guys, I'm giving you buzzwords and showing their uses, hopefully to interest you in them. You can go back to this video and look at this code and say, okay, I'm going to copy the code and use that. But what I want you to do is say, I want this action to happen in a game. I need this to happen for the mechanic I want to build. Hopefully stuck in here somewhere stayed the words that I was saying. That's like, there's a tool for that. So when this is called math tools or development tools, and this one's called tools, I'm just exposing you to the tools, right? So LERP's really easy. If I wanted LERP to happen, I already have my color that I'm messing around with. So my jump works, and I already have the color thing here. I could still do, if I just wanted to LERP this, color is, it's a color. I think there's LERP on color. Color.lerp. There totally is. So there's color.lerp. And you call your lerps and your update functions because they need to happen again and again and again and again, right? Basically what happens is there's a value, or think of it like a point. Think of it like this. There's a point, and say this was red and this was green. update's going to get called a bunch of times, and every time you give it a step to start moving towards that value. So all these values will start moving towards the values that make it this. Now this can be a vector, it can be a point. If I wanted to make my vectors another, if you want to make something else. So say I was looking here, and I made a vector to Van Allen, and I was like, all right, please make my forward vector, the vector I made here. My character would slowly, at some speed, turn to you. If I wanted to turn red while I was doing that, because I was very angry at him, right? I could do that. I could say, lerp my color too, by the same amount. So these fun kind of things that you guys want to do, we can get. And we'll just lerp the color real quick. I don't need you to be a master of this. You will master this on your own. I need to expose you to it. So when you sit around and you ask me a question, or you say, I want to do this in my game. I want to get angry. How do I get angry? It's like, well, turn red. It's like, yeah, but just flipping his material red doesn't give the player enough time to know that he's getting angry. How do we give him time? It's like you'd lerp it. So we're going to lerp a color, right? What color are we? We're color red. Actually, we're going to lerp this color. We're going to lerp our color. And this function takes in 2 colors. And all lerps take these in. They take in A, whatever the hell it is. If it's a float, if it's, I guess you could lerp it. I don't know. I don't think you can lerp it. It could be a vector. It could be a float. It could be a color. It's basically turned this into this over this much time. So I'm going to go to,
Red.
I'm already red. Green? Who said it? I can't hear you. Pink. That is magenta again, is what you're at. It's the only thing they give you is magenta. And we're red going to pink. That's not enough. It's not enough change.
Magenta is enough change.
You could make it
Have you
blue.
seen magenta?
Black, yellow.
We'll go to let's go to something colder. We're in the blues fine. Colder, yes. There's warm and cold colors. We could go to black.
Baby eggshell.
So float T is the float for combining, literally interpolates between colors A and B by T. T is going to be the step that how many steps I take to get there. So if I was running at 60 frames per second, if T was 0.1, whatever the math is to get that there, that's how many steps I'm going to take to get there. So the smaller I make that, the longer it's going to take. Right? If I made that 1 in 1 step, think of it like this. This is at 0. This is at 100%. It is now in its final form and has transformed from whatever it was into what it's going to be at 100%. That 0 and 100% is denoted a lot of the times in programming as just 0 and 1 because we're looking at percentages, right? So 0.5 is what? Half, right? So I'm halfway there. Halfway where? It doesn't matter. Halfway to wherever I'm going. 0.5 is half. So if that vector, if I wanted to lerp from me to Tampa, right, over some time, halfway there, if I did that in one shot, I would teleport halfway between me and Tampa, right? That'd be great, right? If we had lerp in real life, but we don't. So, but so that if I put 0.5 in there, it's going to do it in 2 steps. Does that make sense? So it's going to go like bam, bam. It's going to be really quick. So I'm going to put in 0.01. Or I could do something else. I could just do time dot delta time. Did we talk about delta time?
But delta time is world time.
Delta time is not world time. Is not delta time. Hold on. I need to set this. This is what I'm not doing.
Change the first.
Do you see how it did that over time? Super cute, right? It's too abrupt, right? So if it's too abrupt, then delta time was too abrupt. What delta time is delta time gives you the time between frames on your computer. This is an important concept for you guys to know. Time between frames on your computer. So when we say 60 frames per second, what is delta time?
60 seconds. 60 seconds per second.
What is delta? The difference is 1/60th of a second. So when we say your FPS is at 60 frames per second, that means your program is running. Update is being called 60 times in 1 second. Right? That's super rapid fire machine gun happening right there. When you go slower and slower, and things are happening and you start to chug, that becomes lower. And it gets called 30 times per second, right? When you go down to 5 frames per second, you're in real bad shape, right? That is getting called 5 frames per second. But at 5 frames per second, delta time is the amount of time between each of those frames. 1/60 of a second is much smaller than 1/5 of a second, right? Make sense to everyone? So we use this because we don't want to cheat in games of saying, I wanted to move here. Do you ever see someone just teleport and pop somewhere?
Yeah.
Or have you done that when you were lagging out? Not so. I don't want you to confuse this with internet lag. There's a difference between internet lag and graphical or processing performance lag. On a single player game that has no internet, have you ever got to a point where you started stuttering in frames and moving? Right? Something might have been that, right? It doesn't happen as much anymore. It used to happen. Or if something blows up, there's a lot of particles on the screen and everything kind of goes like, right? We do this because if I wanted to move at a certain point, I will account for the times between those frames. So I will always move the same amount, whether I'm at 160 frames per second or if I'm at 2 frames per second. I will move and do things the same amount. So that's why you scale things by delta time. But we don't have to, we just want to do this for funsies right now. So delta time's know this, delta time's just a really small number most of the time. Just a really small number. And if I made this a smaller number than what delta time would be, it'll say you have a compiler error, and I don't like you. I don't need time.
Oh, you don't need time?
So it's going, man. It is taking its sweet time to get there. But I know that when over that amount of time, I will get from red to blue. Same if I wanted to move a position in the world. If I wanted a platform or a moving wall to get somewhere, I'd say, I want you over there. And I want you to take 1 second to do it. You could tell it, lurk over there. So this allows you to move things, controllably move things if you're using position vectors, but it allows you to make one value another, exactly that other value, over some amount of time. So I want you to think about lerp like that. If that ever comes up in your mechanic design, it said this thing needs to become this. And I told you, it could be a forward rotation. It could be, you have control over time and value at that point. Make one thing something else over a certain amount of time. Now, this isn't like make a model morph into another model, which you actually probably could do with lerp. It's not like transform a dog into a cat. That's not what you're thinking about. But it is values. Transform one piece of data to another value.
But if you had
over
two
time.
models of a dog and a cat, could you?
Sure, you could definitely morph the verts from one to the other. If they had the same amount of verts, and you could definitely morph stuff to do that. Okay, so we learned about a lot, but we didn't learn about, hopefully you learned a lot. That's why you're here. But the concepts we went over 2 major concepts. We recapped vectors a lot, because I'm going to talk about those till I'm blue in the face, because of how important they are and how much you're going to use them. But we really covered the concept of raycasting and lerp. Those are the 2 tools you should have taken out of this, right? And so I did this in script. There is lerp and there is raycasting in generic behavior. You can look under calculations in generic behavior. I think raycast is in there, and I think the result gets stored. I don't know where the result gets stored for that. It is a little more convoluted to teach through generic behavior. But so when we used arraycast, we used it in multiple ways, but it is just array. Array is what? Like, what is the stupid term I was using for it? Laser. It is your laser that does what for you? It hits stuff.
It gives you an output.
It gives you the output. The output raycast hit gives you is what?
Kill the enemy.
No, kill the enemy. Something
No,
we
it
did
just
inside of
tells
it.
you- It just tells you if you hit it. So
If
that
it
way-
was a bool, raycast just said bool. I hit something or I did not hit something, right? Most of the time, raycasts are infinite, so if you don't control the length of them, they will hit something unless you don't have anything out there, right? But we had to use a raycast hit to get our information. Once we had the information of what the hell did I hit, we could say, all right, give me its tag. Let me check that. Now I can see what I hit with that, right? We flipped it down. We used it to make feet. We used it to make eyes. You could use it to make, you could use it for a lot of different things, right? You could use it as a mouse pointer if we shot one through the mouse. So your mouse now shoots lasers, invisible lasers into the world that tells you what you're clicking on. And then we learned lerp. Lerp. One value to another value over time. Those should be filed into your toolbox of awesome things for when you want to do things, cool things. Okay.